Hey friends, it's MoNaCo here. In our second video in our moles and stoichiometry unit, one of my colleagues pointed out yesterday that I made a mistake in it and I had to record it again. So here we are. We're talking about percent composition of any element within a compound. So we're going to be using our gram formula mass to perform this process. You're going to need a periodic table and a calculator as you go through this business because that's what it takes when we have to do our gram formula mass stuff. Why would we do this percent composition? Well, percentages are a type of ratio, and sometimes we need to know how much of the elements in one compound are due to a certain element. So that's why we do percent composition. So we're going to talk about ratios, essentially. So calculating percent composition. The first part of any percent composition calculation is to do the gram formula mass calculation. So in this example, we're going to calculate the gram formula mass for the compound calcium chloride. For ease of calculation, I'm getting rid of the decimal places, as we'll be doing most of that in our class. So 1 times 40 is 40. 2 times 35 is 70. Now, these are the parts that are due to the calcium and the chlorine in the compound. We got to get the whole, which means that we had to add these up. So we add them together. 40 and 70 is 110 grams per mole, because that's the units for gram formula mass, according to the first video, GFM, grams per mole. That's the whole. Now in percent composition, we take it to the next step. We take the part that we're interested in, divide it by the whole that we just calculated. So we're going to use that formula in the second step to figure out the parts that are due to each element. So the part that was due to the calcium element, the 40, is divided by 110 here. So we're going to use this percent composition calculation, which you will find on table T, to do our part calcium. So the percent calcium equals 40 divided by 110 times 100. Well, that will be your answer for percent by mass calcium in CaCl2. Now to do the chlorine part, percent that's chlorine, percent of the mass that's due to the chlorine, you take the other part that was due to the chlorine, which was 70. 70 divided by 110 and multiply by 100 to get an answer that's percent by mass Cl in CaCl2. If you want to check, you should add both of these up and your percentage should add to be 100 because that's how percentages work. Okay, so these are two-part processes, two-step problems. The first step for this one is what's the percentage by mass of carbon in CO2? Well, you have to, one, find the gram formula mass of CO2. That's our first video. Take the number of atoms, multiply by their atomic masses, add the totals up. Then step 2, you have to apply the percent composition calculation. Now, it's asking for carbon in CO2, not the oxygen, so you just do that for the carbon. I want to see in your completed homework that two-part process, the gram formula mass of CO2, that's number 1, and then the percent composition, that is carbon. So you have to do the calculation to get your full credit on your homework there. And this next problem is, again, the same two-step problem. What is the percent by mass of nitrogen in NH4NO3? Well, you got to do the gram formula mass of NH4NO3 first. That will be the first thing that you do. Calculate that. And in the second part, you'll take the nitrogen percent composition of nitrogen in said compound NH4NO3. And I want to see your calculation set up and answer in order to get your full credit there. Let's see. This problem has one more precursor step because it's asking what's percent by mass of oxygen and magnesium oxide. The only thing that you don't know is the formula here. So we go back to our previous unit and we look at the charges of that ionic compound. Mg is a +2, O is a -2. So that formula, when we combine it in its lowest whole number ratio, is MgO. So the first thing you're going to do is find the gram formula mass of magnesium oxide. Then you are going to do the percent composition. In this case, we're asking by oxygen, percent comp of oxygen. I want to see your calculation set up and your answer for full homework credit. So there's one other situation where we would do percent composition. It's for hydrates, and we're probably going to be doing a lab on this. A hydrate's a special type of compound. It's crystal usually, which ions are attached to one or more water molecules. So this little dot in their formula tells us that there are water molecules built into the formula. Things that don't have water molecules are called anhydrates. So these are hydrates. They have water in their formulas. Now, when we do a percent composition of hydrates, we're usually asking what percent of the compound is due to the water molecules. And we do it the same step. We do the calculate the formula mass for the hydrate first. Sodium is 2 times, we're going to round, so we want to use 23. Carbon's 12, oxygen 16, and H2O. Well, there's 2 hydrogens and 1 oxygen. So 2 hydrogens, 2 times 1, plus 1 times 16, so 16. The total gram formula mass for a water molecule is 18 grams per mole. If you're going to memorize anything about gram formula mass, it should be that H2O is 18 grams per mole. So when we do a multiplication across, we get a 46, a 12. 16 times 3 is 32, 48. Wow, 48. And 18 times 10 is 180. When we add all these together, 46 and 12 is 58. Plus 48, that's 106 plus 80. 106 plus 180. Now, I hope I did my math right. 286 grams per mole. Let me just check that again with a calculator. 46 plus 12 plus 48 plus 180. 286. Sweet. So our whole in this case is the hydrate is 286 grams per mole. The second step is like every other second step for percent composition. You got to take the part that's water and divide it by the part that's the whole and multiply by 100. So we're looking back here. The part that's due to our water here is 180 grams, right there. And the whole is 286. So we're going to do 180 by 286, so percent by H2O equals 180 divided by 286 times 100, and that gets you the answer. I want to see that calculated out for credit on your homework. Again, this next problem is exactly the same way as the previous one, except that you have to do first gram formula mass of the hydrate, BaCl2 times 2 H2O molecules are attached to that water, to that particular compound. And then the second part, you're going to do the percent comp, in this case, H2O. Okay, again, I want to see that in your calculations for your homework. Now, I don't expect you necessarily to know how to do everything at this point, but you should have an idea on how to do these problems. First step, gram formula mass. Second step, percent composition. In this particular problem, and it's often asked, is what is the compound that has the most percent by mass oxygen? And so you do the calculation steps 4 times, and you see whichever one has the most percent oxygen, and that's your answer, A, B, C, or D. It's the one that has the highest percentage. Now, at this point, you should have some basic idea of how to do gram formula mass and follow it by percent composition. There's a couple pages in our practice pack that we're going to use to practice, and I've put a little 5 multiple choice question summary assessment on Castle Learning. So thanks for watching, and sorry I screwed the video up the first time. Got to be paying attention to details, because if you don't, you make big mistakes in chemistry. Have a good one.